So our next talk is going to be AI-powered performance insights, integrating OVS OVN automatic performance regression analysis with LLMs. And our speakers are Joe Talarico, Mohit, who's not here, Raul Sevilla, and Jose Castillo.
Thanks, Dumitru, and good morning, everyone. So we'll be discussing about our automatic performance regression framework and how we integrated that with LLMs. I think it's not. Can you guys hear me well? Okay. So Joe, Raul, and I, Joe has been 12 years, I guess, in Red Hat, Raul 10, myself 6 years. We are all part of the OpenShift Performance and Scale department. So I will be briefly providing some context about continuous performance testing and shifting left. Then Raul will be discussing some of the tooling that we maintain for that purpose. And finally, Joe will discuss the LLM integration. So the problem is that performance testing used to happen too late in the pipeline. So when I joined the department, and this was like 4 years ago, this is how it usually works, especially for platforms and use cases which are more difficult to automate, like bare metal or telco use cases. So we usually received like a release candidate or an early candidate in the performance department that then we needed to test. What's the issue here? This is too late, right? If we find performance issues, it's super expensive at this point in time to fix them and to work with development teams to have the proper quality of the product in time. So that's what the problem that we had, and that's what we are trying to fix. And within performance engineer, there are two trends, right? Shift left or shift right. Shift left is moving the performance testing closer to the development cycle. Closer to the development cycle could mean payload jobs, early candidates, but it could even mean the pull request itself or the upstream development itself. Or we could shift right to the operations and day two. So we opted for shift left, and over the past years we've been making a huge effort to shift left most of all performance testing across all the platforms and all the product layers. So in this context, what's CPT? Continuous performance testing is the practice of being constantly making performance testing across all the product life cycles. As I said, pull requests, early candidates, payload jobs, and release candidates, and obviously general available products. And we try to meet the developers in their CI. So in this case, talking about Kubernetes, OpenShift, we are using Prow. And this is fundamental to be able to speak the same language as the development teams do. And this is our basic workflow. Our workflows are ephemeral in the sense that we don't keep the clusters around. We usually deploy the cluster, the Kubernetes OpenShift cluster. We run a number of performance tests on it. We export the results to an external Elasticsearch instance. And this is the interesting part, where we run some automatic performance regression testing on top of that. So we have so many data. The matrix is so big that we need some automatic performance regression analysis to make sure we don't miss any possible performance regression. So why CPT? We have an earlier feedback loop, so we are able to detect earlier in the product life cycle if there's a performance issue, reduces the overall testing costs, and also a nice outcome of this automation is that we are able to test so many more platforms. So we actually have coverage of like over 5 platforms and a number of layered products on top of Kubernetes and OpenShift, which is a great problem because we have so many data that we started looking into these automatic performance regression frameworks and change point detection strategy to be able to make sure we are able to detect those performance regressions. And this is where we are today. So we are finally able to be closer to the development cycles, to the downstream. We are able to run performance testing within the pull requests themselves. We are able able to run performance testing in the payload jobs, in the early candidates. And so we have a schedule where we daily run these tests on a number of platforms. We are missing, as you can see, the upstream. And actually, this is a discussion that we would like to trigger with you guys during this event, because probably OVN Kubernetes would be a great place where we could fit some performance testing earlier in the cycle. So looking forward to discuss this with you during this event. This is obviously a cultural shift. What I like to highlight from this slide is the part of the performance as part of definition of done. So this is where we would like to be. And obviously this somehow changed our relationship with development teams and quality engineering teams as well. So it had some nice impacts about this new model. And specifically talking about OVN, OVS, and OVN networking, this is like some work for 2025. We have new workloads about UDN, layer 2 and layer 3. We also have specific QVirt UDN workloads, network policy, egress IP, and BGP. This is where we have been focused this year, more than 30 downstream bags. There's some tooling that Raul is going to show us next. And we have a bi-weekly engagement with OVN teams. And we also cover much more than OVN itself. Obviously, we cover not only OpenShift, but all the layered products on top of OpenShift. We are talking like multi-cluster management, multi-cluster networking, and all of that. 5 platforms, which include bare metal and several managed services and cloud providers. I'm saying this because, for instance, within OpenShift virtualization, we have some specific OVN tests for QVirt and UDN. So we are trying to cover as much as possible, and this wouldn't be possible, of course. This level of this matrix of coverage, which includes a lot of platforms and a lot of versions, like older versions that are LTA and stuff like that, and newer versions, and this wouldn't be possible if it weren't for this automation that we are mentioning. And now Raul will cover the tooling. Thanks, everyone.
Okay, thank you, Jose. So I'm going to talk a little bit about tooling. So regarding the tooling, we have this splitted how we perform tooling. We perform benchmarking in control plane and data plane. For control plane, we mostly use KubeBurner, which is a tool we use to create a high density of objects in a cluster, the given cluster, so we can measure different KPIs like pod ready latency. We can measure the hardware usage of the different OVN/OVS components, and also we can track basically the pace fail of the benchmark itself. Those are the main KPIs. One of the most relevant ones that has been proved to be more useful has been the pod/VM latency, which is KPI that shows up many other relevant and potential bottlenecks from the taken from the pod creation that involves CNA latency, control plane, container runtime latency. It has provided us the ability to detect regressions in the QAPI server, OVN components, container runtime, kubelet. So it involves a lot of components. This simple KPI can be really relevant and has been proved to be pretty useful, as I said before. The regular pipeline of KubeBurner job is basically to start what we call a series of performance watchers. In this case, are watchers to track things like the VM/pod latency, or we have even watchers to perform periodic profile information collection. And after that, what we do is to run the perfect scale jobs we have defined in the configuration file. Once we have those when those jobs have finished, we collect the series of metrics, predefined metrics from the watchers, I said before, and a series of predefined Prometheus metrics, and we push them into an external indexer to be analyzed later by or by other tooling or even the user. And after that, we finish the benchmark. All of this pipeline is basically integrated within the cloud jobs. Regarding data plane, we have a couple of main tools. One for what we call east-west networking. In this case, we are using KSNetperf, which is a tool that takes care of deploying in the big event cluster the benchmark infrastructure that can be broken down in client-server pods that we use, and we are able to support multiple drivers like netperf, uperf, iperf, and this other one was the name. Yeah, exactly. Thanks, Jose. And we are supporting multiple scenarios like pod-to-pod via SDN or host network, pod-to-service communications. KSNetperf, apart from deploying the infrastructure for the benchmark, it drives the benchmark itself, collects reads the benchmark results, normalize the results, and send them out to an external indexer as the same way as KubePartner did before. And after that, it garbage collects the benchmark assets to leave the cluster at the same state it was initially found. For data plane tooling, we use IngressPerf, which is yet another wrapper on top of an HTTP load driver. Follows the same pipeline, deploys the benchmark assets, drives the benchmark orchestration using different drivers. At the moment, we are supporting, I think, Work2, Vegeta, and what else? No. Well, something we built in-house that was called AIDS Loader. Yes, but it's not very simple HTTP loader application. Well, we are supporting at the moment regular ingress controller API in addition to gateway API. So we are able, with the same tooling, we are able to perform benchmarks with those two ingress APIs. Again, drives the benchmark execution, collects the results back, normalize them, and it is also able to index them in an external database, along with some Prometheus metrics like the ingress controller, CPU or memory usage, or some relevant metrics that are actually hard-coded in the code at the moment. And after that, it garbage collects the stuff it created. So regarding regression analysis, once we have all that information indexed, I talked about analyzing it. So for that purpose, we have built Orion, which is our performance regression analysis framework that basically works by querying the data warehouse for the results matching a given fingerprint. Once we have the IDs for matching that fingerprint or that metadata, Orion is able to collect the specified metrics for that from those UIDs, from those IDs, and analyze them using the provided analysis algorithm that we normally use eDevice, provided by the Apache Ottawa project, former Hunter. That has been proved to be useful because analyzes the current ID with a sliding window of previous IDs, so we are able to detect regressions on upwards and downwards trends in the metrics that may reflect a potential regression. This is how an Orion configuration file looks like. So as I said before, we are adding some metadata filtering there. The stuff that is in curly braces are variables that can be potentially passed through flags or environmental variables. So for this specific configuration test, we are matching jobs from the AWS platform, self-managed cluster, using those kind of instance sizes for the master nodes and the worker nodes. We are matching cluster density V2 results. That is in this case, it's a workload we run with KubeBurner, and we are matching an arbitrary OCP version that is passed that is specified from a flag, and we are matching results from the OVN Kubernetes CNI, and in this case we are defaulting to periodic kind of jobs and not matching the OKD jobs in this case. Yep, that's pretty much it. And this is how a regular Orion output looks like. So in this case, it has 4 columns here. The first column is depicting the versions analyzed that are matching those UIDs retrieved with the metadata filtering. And the columns in the right are reference the metrics we were analyzing in Orion. So the first metric we were analyzing was pulse ready latency, which in this case was 4,000 milliseconds, 4 seconds. But as you can see here, there's a potential regression here, but it didn't fire an alarm because the results went back to normal. So it was basically an isolated spike in that case. In this case, we are also tracking the vSwitch CPU observed across all the workers in the node, and also I think it's the OVS CPU. I don't know what is the difference, actually. Well, it's another vSwitch CPU metric as well. And next slides are yours.
Okay.
Yep.
All right. Cool. All right. So we've gone through kind of the workloads that we run in our workflow, and hopefully it was obvious that in our workflow, we run our benchmarks, we collect metadata, and that metadata is descriptive of the system under test. So we collect things like what was the CPU type, Intel, AMD, et cetera. What was the architecture? We don't get into super low level details, but when we collect these fingerprints, it allows us to then segment our data and say, hey, I only want to see bare metal results that had, let's just say, 100 gig networks. Or I only want to see results that have this version of CNV. So when we're able to do that, one of the obvious questions we started to run into is how do we make our data more consumable outside of our team? Because what we ended up finding was, yes, we have all this cool tooling. Yes, we're running it in Prow. Yes, we're on periodic. It's great. But when we run into a regression, or if a developer runs into an issue on a PR, it's not intuitive for them to figure out why it failed. Because our tools, for example, Orion, when it identifies a regression, in CI, all we can report is a 0 or a 1. We can't really get into the low-level details of why did it have a regression. There's no triage. So we developed a tool now to take Orion data and then combine it with an LLM so a user can then say, hey, how is OpenShift nightlies running? Or you can say, hey, how is OVN Kubernetes running in OpenShift? And we can get, again, it's going to be high-level details of basically the Orion MCP will query based on your fingerprint that you provided to it and say, hey, are there any regressions? And if there are, we add additional metadata that provides the PRs that were part of the payload to then pass that to the LLM and say, hey, use a web search tool to hit GitHub and find me the likely culprit that introduced this regression. So again, it's going to use high-level details from the PR descriptions to kind of help us isolate. One of the points that Jose made was we want to move our testing upstream for OVN Kubernetes, because what we have found in OpenShift is we do these large downstream patches, and it's very difficult to isolate the patch set that introduce the regression. And this is not unique to OVN Kubernetes. This is pretty much every project in OpenShift. We have a downstream merge of kubelet, of cryo, of all these things, and it's hard to isolate performance regressions when they're found. So we're hoping with tools like what we're building here, where a user can ask very high-level questions to an LLM connected to our MCP server, has my PR introduced a regression? They can start getting answers quicker. All right, so I don't have to rely on the demo gods. I have a pre-recorded thing here. So this is using, I think I used Claude. Yeah. I don't know if it's visible, but what I'm asking Claude here is I'm asking what tools are connected and provide an explanation for each tool. Oh, that's not the button I wanted to hit. Let me go back. All right, sweet. So all Claude's going to do is do a list tools and then get a quick description of each tool and then provide it to me, the user. I'm going to skip ahead just for time's sake. All right, cool. So here are the current tools that we have. Obviously, we want to know, because we're OpenShift performance engineers, has OpenShift regressed? We also have specifically for networking, which would be OVN Kubernetes. We're going to look at something for just UDNs and for CNI density. Those are just two workloads that KubeRunner runs. We have a report on function that will generate visualizations. And then we have a new one that I just added recently to report on a PR. Now, today, the report on PR only works on our downstream OVN Kubernetes repo, but we would love to talk about adding this to the upstream OVN Kubernetes repo where a user could get the same kind of insights. All right, let's continue. Let's skip ahead. And then I'll tell you the prompt. Sweet. So the next prompt I asked was, has OpenShift 421 seen a regression in the last 20 days? If there has been a regression identified, identify which of the PRs could have introduced the regression. Use a web search tool to investigate each PR and provide the probability the PR introduced the problem. This prompt took a while, so I'm going to skip ahead. Let's see. I'm going to struggle to skip ahead. So the first thing that the tool did, which I missed, was it did a tool call to Orion MCP asking if there was a regression in 421. And then in the background, Orion MCP is doing the e-divisive analysis against multiple configurations that we deem important, right? And that can be tailored to your specific use case. For example, we're working with the StackRox or ACS team. They have a different use case than us to determine if there's a regression or not. So we can see that 421 has experienced a regression in the last 20 days. We see that this workload here, the node density workload, the API server saw an increase of 10%. And then we also saw that the node density CNI, which is a OVN Kubernetes workload, saw a 16.37% increase. So then, as I instructed the LLM, I wanted to then do a web search because, in the payloads that I send back from the MCP server, I add additional metadata that has, for each payload that OpenShift has, tell me the PRs that were introduced. So I know everything from the downstream merges for OVN Kubernetes to kubelet to everything in that went into that nightly build or into that payload build. So then the web search are happening. Skip ahead for time. All right. Sweet. I think I missed where I did it. Oh. There it is. All right, sweet. I'm gonna pause it here. So since I asked for the probability, it's gonna give me a high, medium, and low probability of which PRs introduced the problem. From here, I can either do my own personal analysis of looking at the PRs, but it at least isolates a handful of PRs for me to look at versus taking this massive digest of changes and commits. Now, do I believe that there's a high probability that, you know, etcd operator introduction of this new change made this problem? I don't know, but I can at least focus there and then kind of go on and look at the medium and low probability. And then next slide. Cool. So another type of integration that we're considering doing, and we have a proof of concept working today, is a lot of us use Slack. And a lot of us don't want to have to connect and have your own LLM running against Claude and connect to an MCP server. So it makes sense that if we had a Slack bot, a developer doesn't have to connect their MCP server. They don't have to do anything. They can just go to Slack and say, hey, here's my PR. Tell me what was introduced. Like, tell me, do I have a regression in this PR? And this is that running today. So I actually provided a OVN Kubernetes PR that's downstream that compares, what you'll see here is a baseline. So the baseline is the periodic runs that we have. And then we collect the PR data to say, hey, here's the comparison that your PR introduces from the baseline. So either we want to see, we don't want to see positive values here. We'd like to see negative values here. Obviously, there's like an OVS CPU workers. It's 5.96% change for the CPU. Honestly, that's noise. So there's nothing here that we'd be concerned about. Obviously, we would want to work with the developer more before they merge this in until we continue to validate these things. But ultimately, we're hoping that something like this like demystifies a lot of our performance data for developers and for users, so they can get a sense of, hey, my PR either is breaking things really bad or it's not that bad at all, low impact. I have another quick demo that's showing that integration running. So that's the PR. So you can hopefully see here, I'm hitting this specific Slack bot. I'm asking it to analyze the PR, and then I provide the PR, OpenShift, OVN Kubernetes, PR 2841. And then I'm providing the context of, hey, this PR is a downstream merge for 420. I want to make this a little bit better for the user so they don't have to know what the context is of, hey, this is a 421, 420 downstream merge. But right now, this is how we have to make it work. And I will skip ahead again. Apparently to the end. Oh no. Fat finger problem. Here we go. Cool. So as you see, the bot itself responded with the similar output that you saw on the previous slide. This was looking at a different PR. But again, you know, it's going to give us for each benchmark the top metrics. These are not all the metrics we collect. We collect a lot more than this. But this will give the developer a sense of, are things looking good or are things looking bad quickly, or within 2 minutes, right? This is another feature that we're looking to add, where being OpenShift specific performance engineers, we don't know all the metadata, right? So we probably need to work with OVN developers, OVS developers to understand what metadata is relevant to you guys for that fingerprint, right? How do you want to segment your data? So this is a new feature we're adding where you can decorate your results with additional metadata that allows you to do this fingerprinting. So this is just a demonstration of, hey, we want to collect the OVN Kubernetes, and the OVS versions, and start decorating our metadata with this. So an OVN developer can say, hey, give me all the 2509 results for this type of workload. All right, cool. Challenges and next steps. So we'll start with next steps. We would like to be considered to be added to the OVN CI test for one of our performance workloads, start moving some of our stuff upstream, start working with developers to understand, what should we be collecting for metadata, what makes sense for the fingerprinting. So, catch, Raul, Jose, or myself to discuss this and how we can start moving some of these tests upstream. We do have an idea for an agentic workflow for CPT, where when there is a regression found, we still have that massive commit list, taking each commit ID, creating a payload, running our performance test, and trying to find in an automatic way which commit with a high certainty introduced the regression. So instead of us, performance engineers taking each commit and finding it, if we could have an agentic workflow that does that for us. Of course, in testing, increased testing coverage, local nets, all the UDN stuff, additional like EVPN for BGP, all the cool things, get that added in. More metadata, more integrations. Thank you.
Do we have any questions? I see one there.
Question. What is your baseline? You have the baseline that you compare to. So what?
Yeah. So the baseline is if the user asks for 421, we collect all the payload data. So the payload is not nightly runs, because payloads in OpenShift happen before nightlies, but we collect all the payload runs and then compare it to the PR. So our baseline is everything that's made it into payload for that day, for that time. So that's our baseline. Like we used to do this concept of a golden UUID and compare everything to just one set of runs. And we found that to be just cumbersome, because we'd always have to re-baseline and get a new golden UUID. So we don't do that anymore.
Alright, MCP is running on AWS somewhere?
No, it's running internally.
On your laptop or?
Well, so for when we developed it, yes, it's running on our laptop, but I do have a hosted Orion MCP. Oh, yep. The question was, is Orion MCP running in AWS? It could be, right? There's no reason why we couldn't host it on AWS. It's connected to our OpenSearch instance. So it's connected to our data warehouse.
Yeah, right. If you have to move this to our Kubernetes upstream, right, we would want to run it there and then provide it access to a bot account which can talk GitHub. Start checking out like agentic AI, and now we have to kind of start working with you on that, I would think.
Yeah, absolutely. So we already have teams outside of our performance team that are using Orion MCP against their data stores. So like all of our stuff is pretty generic. So we could easily work with the upstream OVN Kubernetes environment to get that working and make it a more public asset.
Yeah.
Yep.
Any other questions? We have time for one more, I guess. I do have a question, actually. You spoke a lot about adding this to OVN Kubernetes upstream. Do you think it would be interesting to add it even further down the stack to OVN and OVS upstream?
Yes, I think that would be awesome. The one area that I thought would be cool would be the OVN heater. That unless that's not running your CI, like my idea would be if there's already some sort of like scale and performance test that you run, like OVN heater, could we take, there's a report that generates an HTML page. Instead of taking an HTML page, could we create like a JSON payload that we send to Elasticsearch with all the metadata that we need and do a similar kind of pipeline, but using OVN heater. So that just becomes a new workload that we run.
Okay, cool. Yeah, I guess we're skipping a step now because OVN heater doesn't run upstream yet. So we could do both, I guess. Yeah. Thanks.
Okay.
There's another question in the back. And I think it's the last one.
So I think some of the integrations you've mentioned are reactive. Like I opened up YAR, I did something, and then I ran the AI. But have you considered anything proactive, like AI runs nightly and runs the query to MCP just to discover something, and then there's a notification that something happened?
Yes. So Jose looked into this for Prowl. For some of the pipelines, there isn't a intuitive way to have like a bot in Prowl today for us to do this, but we have a tool called Bugzooka, and that was the Slack bot. But we could potentially have it listen to webhooks on a specific GitHub repo and have it be proactive versus the user saying, hey, here's my PR URL. We could listen on a webhook and then have the message be sent to that PR. So yeah, so I mean, we have ideas on that, and yes, we'd like to be more proactive than reactive.
Yeah, I wonder if coming back to the previous presentation of configuring Claude or any AI to review PRs, whether those could be nudged or configured to also look at the results of the performance drops, etc., to give you a summary instead of me asking for it.
Yeah, so in Aaron's presentation, you saw a message there about no MCPs configured. I wonder if we could just drop in our MCP and then that just gets, asked. Yeah, that'd be cool.
Thank you.
Okay, let's thank our speakers again.